Welcome to part three. Part three. This is question number 12, I suppose. Um, the figure shows a circle centered at the origin with the angle measure of theta. Great. In radians. In standard position. Sure. So that is theta right there. And point P on the circle. Point P. Yep. Okay. Here's point P. The terminal ray of the angle intersects the circle at point Q, okay? And the length of PQ, that is this part right here, is 6 units. Which of the following gives the distance of point Q from the y-axis? So we need the distance from Q from the y-axis. So we want this one right here. So that's the y-axis. We need this distance right here. We'll call it D, or actually we just call it X. We can call it X. Great. So this arc length is this. This is theta. We have this. This has a radius of 5. So we know that this is 5 because point P is 5, 0. So our radius is 5. And so we need to know what is the cosine value. What is the cosine value of the angle? So the angle should be equal to, so the angle in radians, our angle in radians is equal to the arc length over the radius. Back to this formula again. So I have arc length, I have radius. So that means that my angle should be arc length, which is 6. My arc length is 6. My radius is 5. So my theta should be 6 over 5. So I pretty much have this triangle right here. This is 5, and this angle is 6/5. So it wants to know what is the x value of this point. Well, the x value is the cosine of that angle. So the x value is cosine of 6 over 5. So we should get D, 6 over 5, 5 sine of 6 over 5. So it's R, oh, not sine, sorry, should be C. 5 cosine of 6 over 5 because we do R cosine theta. R is 5 cosine of theta. Next one. The figure shows a circle of radius 2 along with 4 labeled points in the xy plane. So we got A, B, C, and I guess O is the other point. The measure of angle COB. So the measure of COB is equal to the measure of AOB. What are the coordinates of COB, AOB? So this is worded poorly. But I think I know what they're trying to say. If you were really doing COB, you would follow counterclockwise COB, so you should fill this whole thing in here, and then AOB with this part right here, but I think they messed up. I think they meant to say BOC and not COB, but we'll just correct that. So we know that those two angles are the same, which means that what are the coordinates of point B? So point B should be R cosine theta, R sine theta. Should be our point right there. So R is 2. So look over here. A and B don't have a multiple of 2. The coefficient is not 2. And this angle, well, all of these say 7 pi over 4. So that should be 7 pi over 4, which we can check our unit circle and see that that is true. So we should do cosine theta, sine theta, x is cosine, y is sine, so it should be C. Okay, next up, number 14. In the xy plane, an angle in standard position measures at 5 pi over 6. So let's sketch that out real quick, whether we need it or not. 5 pi over 6, that is a nice special angle. So it is right here. So this angle right here is 5 pi over 6 in standard position. A circle centered at the origin has, so we have a circle as well, and it has a radius of 4. And so we have that point there. What are the coordinates of the point of the intersection? So we want to find these coordinates right here. Well, these coordinates are r cosine theta, comma, r sine theta. So let me put my unit circle on. We can keep my unit circle out. So r cosine theta, so this is going to be 4 times cosine of, I'm off the screen, 5 pi over 6, comma, 4 sine 5 pi over 6. So we can find cosine of 5 pi over 6 and sine of 5 pi over 6 really easily. There's 5 pi over 6. Cosine is negative root 3 over 2. So that's going to be 4 times root 3 over 2, comma, 4 times sine of 5 pi over 6 is 1/2. So 4 times 1/2. So those are our coordinates. Simplify this. 4, so this would cancel out the 2. That would make this a 2. So we should get negative 2 square roots of 3. And then 4 times 1/2 is just 2. So I should have negative 2 root 3, comma, 2. Negative 2 root 3, comma, 2 is option A. Awesome. Awesome. Burning right through these. Burning right through these. Let's get one more page on this video. Okay, 15. Angles A and B are in standard position on the XY plane. Okay, so we have XY plane. We have angle A is 2 pi over 3. So 2 pi over 3 is somewhere right here, so we'll call that angle A. And the measure of angle B is 4 pi over 3. So 4 pi over 3, if you can't mentally picture that, check the unit circle. Anything over 3 is going to be a fancy spot on the unit circle. 4 pi over 3 is right down here. So we should have a spot right there. Okay? The terminal rays of both angles intersect a circle centered around the origin with a radius of 20. So there is this giant circle around it. So this right here is B. And the radius of this circle is 20. 20. Make sure, like this I might have written too small here, but make sure you write big. You're not gonna, it's fine. Write as big as you need to draw all the things in your beautiful, beautiful artistry. Okay, so we want to find the distance between 2 points of the intersections. So we need to find the distance between here and here of the circle, the terminal ray. Yep. So we need to find what is the distance from here to here. Well, luckily, these are part of the same family. They're both over 3. So if you look at this, this is 2 pi over 3. This is 4 pi over 3. Both of these will have the exact same x value. So there has been no horizontal movement. We just need to find the distance from here, the y values. We just have to do y2 minus y1. So really all we know is since the x values are the same, they're going to cancel out. Really, the distance formula is the Pythagorean theorem, but we'll get to that in the future. But now, just the distance between these two. We just have to do, so this is, the x values are the same, so we do sine. We need to find the difference between the y values. So you see the distance between the x values This is for the y. X values are the same. They cancel out. The y values are going to be sine of 2 pi over 3 minus sine of 4 pi over 3, right? And the only thing that's different is that we also need to make sure we account for the size of the circle. The radius is 20, so I need to make 20 and 20. And so usually I could put that into the calculator, but they don't want it. They want the exact answer, and the exact answer is going to be D. 20 sine 2 pi over 3 minus 20 sine 4 pi over 3. Awesome. 16. In the xy plane, the terminal ray of angle theta in standard position intersects a circle with the radius of r. At the point, okay, so another circle has a radius of r, xy plane, yada yada yada. Xy, it intersects at the point 10, negative 10 root 3. So that's going to be a positive negative, so it should be in quadrant 2. Or sorry, quadrant 4. This should be in quadrant 4. And this point is 10, comma, negative 10 root 3. Okay, so the terminal ray of the angle theta in standard position intersects circular radius this. What are the values of theta and r? Well, okay. So we need to figure out, so this is, I know that r cosine theta equals 10. R sine theta is equal to negative 10 root 3. So here's the thing with that, like there's not much you can really tell with this. So we got to try something else. Let's do, well, actually, we can draw a triangle. We can draw our little triangle if we wanted to. So this is theta, and this point right here, this is r, this is theta. Or here's another thing we could do, is just find out we are in quadrant 4. Let's see if we can do a little shortcut. This is quadrant 4. So before I'm going to do a whole bunch of math, this is multiple choice, so let's see if I can cheese this thing. I know that, let's see here. I know that quadrant 4. So which of these are in quadrant 4? 5 pi over 3. Well, 5 pi over 3, that's in quadrant 4. Okay, so you're in quadrant 4, fine. 5 pi over 3, you're in quadrant 4. 11 pi over 6, oh, you're also in quadrant 4, and you're also in quadrant 4. Darn, they're all in quadrant 4, so we can't really cheese it. So then what we're going to have to do is do this right here. I know that this value is 10, and I know that this value is negative 10 root 3, because that is my x and y values. So I could do the Pythagorean theorem. This is going to be 10 squared, 100, plus negative root 10, negative 10 root 3 is going to be, so negative 10 squared is 100 times root 3 squared. So root 3 squared is 3. 100 times 3 is 300, is equal to 400. And we take the square root of that. So we should get r is equal to 20. Okay, so that cancels out A and C. Great. R is equal to 20. Now I need to figure out theta. Well, here is a little trick. If R is equal to 20, this x value is half of 20. Where on my unit circle is the x value 1/2? Right here. So this should be 5 pi over 3. So we should get B. B, because 10 is half of 20, and cosine is 1/2 there. Next up, the figure shows an equilateral triangle, ABO, with side lengths of 10. So we got an equilateral triangle, 10, 10, and 10. Segment AB is perpendicular to the x-axis, so that is a nice right angle. The terminal ray of angle theta, which is not shown, in standard position passes through point B. So it passes through point B. So the terminal ray of angle theta not shown in standard position passes through the point B. What is the value of 10 sine theta? So, hold on. This is kind of hard to read. The terminal ray of angle theta in standard position, so we're starting here and we're going around, passes through the point B. What is the value of 10 sine theta? So sine is our y value. If it passes through point, so I know this angle here, since this is going to be 60, so this is 60, this is 60, this is 30, this is 30. If we look at our triangle here, what it's doing, or it's this triangle right here, these blue lines, and they've connected these points here. So it's either 5 pi over 6 and 7 pi over 6. So this is 5 pi over 6, but then the slightly bigger one right here is 7 pi over 6. But it passes through the point B. The terminal ray of angle theta. Oh, the terminal ray passes through. So it's okay. Sorry, for some reason I was not reading that right. So theta is the terminal ray passes through point B. That is that right there then. I thought it said the angle passed through B. That didn't make sense. But the terminal ray passes through point B. That makes perfect sense. So this is 5 pi over 6. So point B should be 10 cosine of pi over 6, 10 sine of pi over 6, and we want the value of 10 sine of pi over 6. So 10 sine of pi, not pi over 6, 5 pi over 6. 10 sine of 5 pi over 6. Well, sine of 5 pi over 6, check your unit circle, is 1/2. So this should be equal to 10 times 1/2, which should be equal to 5. So remember, this point is r cosine theta, comma r sine theta. These coordinates will save your life. Save you so many points. Okay, this video is now at 20 minutes. I'm going to stop it there, and I will see you in video 4.